Hello everyone, today my group and I will be presenting on Fortran. I am Caique Trivelato and I'll present the versions of Fortran 1, 2, 4, 70, and 90. So Fortran is one of the oldest and most influential programming languages in history. Again, I will explore its evolution from Fortran 1 to Fortran 90, and we'll be looking at its syntax, usage, and impact on modern computing. Just as a background information, Fortran has been widely used in scientific computing, engineering, and high-performance computing applications. So let's begin checking how it all started. It's for formula translation, and it was created by IBM in 1957 under the leadership of John Backus. This was the author. And it was the first high-level programming language designed to simplify coding for mathematical and scientific calculations mainly. But before Fortran, programming was done in machine code or assembly, which was tedious and very prone to errors. And on top of that, I just wanted to point out that there are not a lot of videos or information about every version of Fortran, but specifically you get to know better the history of how it began. And Fortran 1 was pretty much that. And I saw a video that a guy was mentioning how many details you had to know and processes that you had to go through to write your code and run your code and test your code actually. So then you would know that there was a little line mistake, like I don't know, let's say in Python for example, you didn't put in a plus sign in the middle of two variables, and then you'd have to go back through the code all over again, and it would be hard to track the line that the code that you missed, that plus sign, So it's a lot of details, and it was very prone to errors, and this was already in the Fortran 1, so this was a high level, and it was the first time that they were producing that high level, but it's just interesting to see how it improved from assembly to the Fortran 1, and how far along we have come after introducing Fortran 1. But basically, Fortran 1 introduced the idea of compiling human-readable code into machine code, improving programmer productivity by a very perceptive. It lacked structured programming features, but it was revolutionary for its time, like I said. One of the simplest Fortran programs. It prints the text "Hello World" to the screen. It's pretty much an example of Fortran 1 there, so just so you can get familiar of how it would be reading. But the print and asterisk statement is used for output, right? Pretty comparable to the Python, I would say. But it's also important to know that the first line was always like for title, and the last line was for you to end the program, correct? And also how every word and every letter was in uppercase instead of like lowercase and uppercase all mixed. IBM released Fortran 2. It was about 1958, improving upon Fortran 1 by introducing subroutines and functions, which allowed for better code organization and reuse. This version made it possible to break large programs into smaller, manageable sections, right? Instead of like having a whole full code, you could do methods, right? Like little chunks of the whole program, and then you could put it together. But it also added support for compiling separate program modules, making it more flexible for large-scale computations. And while it was still simple compared to later versions, Fortran 2 laid the foundation for structured programming. Fortran 4 was developed in the early 60s and became the first standardized version of Fortran, officially recognized as an industry standard in '66. It removed machine-dependent features and added improved logical and mathematical operations. This made Fortran more portable across different systems, which was a significant improvement over previous versions. Fortran 4 was widely used in scientific and engineering applications, and many of its features still influence modern programming languages today. And this here is a code example of Fortran 4, which calculates and prints the square of numbers from 1 to 5. And again, this one has a title in the first line, then the do loop, which repeats 5 times, setting I from 1 to 5. Also inside of the loop, prints asterisk outputs I times, right? Asterisk 2, which basically means I squared. Another line, the continue statement marks the end of the loop. And also, one thing that is very important to point is that in modern Fortran, do loops don't need labels like the 10 before the continue there, but this was necessary in older versions like Fortran 4, for example, and the end to finish the program. Pushing for 1 decade ahead of Fortran 4, by the 70s, programming needs were evolving, right? So you have more programs being deployed and more desire for evolution of the technology, right? In general, like it happens nowadays, is just more intense as compared to what it used to be in those times. But it was released in 78, Fortran 77, and it was a major improvement. It introduced better character string handling, improved structured programming with if then else, right? One more feature that is very common for us nowadays. At that time, IBM came with this innovation as a statement and allowed for more readable and maintainable code. Fortran 77 became the dominant version for many years and was extensively used in physics, again, engineering, and aerospace in the industries. Marked a major shift toward modern programming practices. It introduced dynamic memory allocation, array operations, and modular programming. So there is a jump of 12 years there since the 78 release of the Fortran 70, and marking another big step for IBM, including arrays that now, and operations of arrays that now we see so much throughout every programming language, basically, right? And important to point out that the new syntax made code easier to read and write, improving efficiency for scientific applications specifically, right, since that was their niche. And it also supported recursion and user-defined data types, making it more versatile. Fortran 90 was designed to keep Fortran relevant in an era where newer languages like C and Python were gaining popularity. So imagine that you're IBM, you have all this code that is old, that is very rusty, and you gotta try to implement as many better features to have a good interaction between the person that is manipulating the code, who's writing the code, and functionality of the code itself. Example of Fortran 90, the program demonstrates modern Fortran features like arrays and built-in functions. In this case, the implicit node statement ensures all variables are explicitly declared, which helps prevent errors. The array A is initialized with 5 numbers, 1, 2, 3, 4, 5, how you can see on line number 3. The sum function computes the total of these numbers, right, on line number 4, storing the result in the variable sum. Finally, the print asterisk statement outputs the sum is 15 on line number 6, showing the calculated sum. And this version of Fortran supports dynamic memory allocation and advanced array operations actually, as I pointed out before. So you have the mix of arrays and the numbers inside of the arrays, and you can kind of play with them in different ways, counting on the built-in functions that Fortran 90 released at the time, and that made life way easier for scientists and people that needed to compute numerical values for at some sort.
Good morning. My name is Harper Rodgers, and I will be taking over from here. I will be covering Fortran 95, 2003, 2008, and 2015. Fortran 95, it was used mainly in the 1990s to the early 2000s. What's different between 95 and 90 is it improved processing for all and where statements. It added useful intrinsic functions like sum for arrays, and it made some clarifications and refinements of Fortran 90 features. An example, so for this code example, we're going to be focusing on the sum intrinsic. As you see right there, the program name is SumArray95. Here's your array with 1, 2, 3, 4, 5. Declaring the total variable here, and total equals sum A. So it's going to take every single number and add them together, and then it's going to print out the sum is 15. Then it's going to end the program. Fortran 2003. What's different or new with this one is it introduced modules to group code into reusable pieces, added basic support for object-oriented programming, and enhanced I/O capabilities. Here's the code example for this one. We will be focusing on the simple modules with a simple module with a function. So here we have the module sum function. In the container is the sum array. So what we're going to be doing and calling the result is the total. So we're declaring the array. Next, we're declaring the two integer variables, total and I. Total equals 0. Now we have the do. Do I equals 1 for the size of A. So the size is 5. As you'll see down here, the size is 5. And then for each position in the size of the array, we're going to be doing total plus A, which is going to be the total plus 1, the total plus 2, total plus 3, 4, 5, and it's going to end that. It's going to end the function, and then end the module. Now for the program itself, we're using the sum module. This is like importing. We're importing this module like we would import into Java. Here's the array. Declaring the total again. Total equals the sum array, A, and then it's going to print out the same thing. The sum is 15. It is then going to end the program. Fortran 2008. What's newer? It was used between 2008 and 2015. What's new or different with this one? It introduced the do concurrent for simple parallel loops. It added support for co-arrays to help with parallel programming, and it improved performance and code clarity for array operations. The code example is going to be focusing on the do concurrent. So as we see here, we start with the program. The program's name is SumArray 2008. Here's the integer, or here's the variables. Here's the array. Do concurrent I equals 1:5. So it's going to do 1 to 5, the total is how we get the number. The sum of 15 is total equals total plus a, parentheses I. So for each number between 1 and 5, 1, 2, 3, 4, 5, it's going to be pulling that number out of here, 1, 2, 3, 4, and 5, and adding that to the total. It's then again going to print the sum is 15, and it's going to end the program. And finally, we have Fortran 2015. It's being used currently, so from 2015 until now. And what's new or different with this one is it made refinements to the parallels and co-arrays. It enhanced object-oriented programming, and it also enhanced the clarity and consistency in language syntax. For the code example, we are going to be focusing on the co-array example. So we have the program name, variables in the array appear. So if this image this is only going to initialize a single array. We do this, and then if whatever this variable is not equal 1, then it's going to do a equals 0, so if there's nothing, and it's going to end the if. It's going to then take the total of the sum of the array and print it out if it's correct. So if it ends equals 1, then it'll print it out. It'll print the sum is 15, and then it will end the program. Thank you for listening to me speak. Have a good day.